Okay, so we're going to look at section 6.4, which has to do with parallel and perpendicular lines. So I'm going to graph these three equations on one grid, and I'm going to graph using the slope and the y-intercept method. So the slope in the y-intercept method is I'm going to use my slope, which is my m, and my y-intercept, which is b. So once again, at this point, you should know that this is in the form y equals mx plus b. My b value is right here at -3. Okay, this method of graphing is easiest if you go by, and I talked about this already in the video of 6.1. So this graphing method that I'm doing right now is a review. You should at this point know how to graph this method because we've done it already. But this method is easiest if you go by a scale and a space of 1 because we're going to do some counting. Identify your b value at -3. Identify your m value at 2. Remember, you always plot the b value first. It equals -3. It's the y-intercept. So at -3 on the y-axis, I'm going to plot my point. Okay. The next thing I do is I look at my slope. I write this as a ratio of my rise over my run. This is the only time I take a whole number and make it into a fraction. I know that every whole number has a denominator of 1. Remember, rise is a movement up or down. If you have a positive rise, you're going to go up. If this rise was negative, you would go down. If you have a positive run, you go to the right. If this run was negative, you'd go to the left. Because this is positive 2, from the y-intercept at -3, I go up 2. Because the run is positive 1, I go to the right 1. So I go up 1, 2 to the right once. Do it a few times. Up 1, 2 to the right once. And I'm going to do about 4 points. Make sure you connect those points with a ruler. Make sure you extend those points and put arrows and label it. Y equals 2x minus 3. Okay, I'm going to do the same thing here. Just use a different color. I'm going to do the same thing I did here. I'm going to first identify my b value, which is 4, and I'm going to plot it. Next, I'm going to look at my slope, which is my m value, which is 2. Once again, it's a ratio of my rise over my run. Again, I notice my rise is positive 2. That means I'm going to go up 2 to the right once. Up 1, 2 to the right once. I do that a few times. Okay. Once again, I take my ruler out. I connect. I extend. I put arrows on both ends. These are both examples of partial variations because both lines do not go through the origin. This is my final line. I notice here that I'm not adding anything to my y equals 2x. So that tells me my b value is 0. Again, I look at my m, which is 2. Again, it's a ratio of rise over run. So I go to 0. Plot that b value first. Again, because this is positive, I go up 2 to the right once, and I do that a few times. And then I connect it with my ruler. Of course, I put arrows on both ends. And I label it. This is an example of a direct variation because it does go through the origin. So, all 3 lines on the same grid. What type of lines are these? I notice they're not going to cross or they're not going to meet. So these are parallel lines. What is the same? What do you notice is the same in each of these equations? Hopefully you tell me. They all have the same slope. So what conclusion? The b values are different. So this b is -3, 4, and 0, but all the slopes are the same. So the conclusion you can make is parallel lines have the same slope. Okay, so let's look at another set of lines which are perpendicular. We're going to do the exact same thing. We're going to graph these. Once again, I'm going to graph it the same way with my m value and my b value. So once again, I go to my b value first, which is +3. I plot that first. I identify my m, which is my slope, -2/3. Always put the negative in the numerator. Okay, now because again, this is a ratio of rise over run, this is a negative rise. So that tells me I'm going to go down. Down how many? 2. My run is positive. That tells me I go to the right 3. So from here, I'm going to go down 1, 2, to the right 1, 2, 3. Do that a few times. Down 2, 3 to the right, and I'm going to just do it one last time. I take my ruler. Once again, I connect, I extend arrows, and of course I label it. Okay, I'm going to do the same idea here. My B value here is -2, that's where I begin. My slope now is 3 over 2. Again, my ratio of rise over run. Because rise is positive, I go up 3. Because run is positive, right 2. So up 1, 2, 3 to the right twice. Do that a few times. And this is why you want to go by a scale of 1s and a space of 1s, because you're counting. Here I went up 3 to the right 2 times, and it's easier if I go by a scale of 1s. Again, I put arrows on both ends, and of course I label it. Okay, now what type of lines are these? These are not parallel because they do meet. They meet right here. And if I pulled out a protractor, this would meet at a 90-degree angle, which makes these types of lines perpendicular. Now there is a relationship here also with their slopes. Again, the B's are different. Let's look at the slopes. This is -2 over 3, this slope. And this slope here is 3 over 2. Do you notice the relationship? One of the slopes is positive. One goes in the positive direction. The other one goes in the negative direction. So one's positive, one's negative. The 3 that's in the denominator here is in the numerator here. The 2 here in the numerator is in the denominator here. We call that a reciprocal. And we call it negative reciprocals. Okay? So what conclusions can we make? The conclusion we can make is that perpendicular lines have slopes that are negative reciprocals. So you flip them and you change the sign. Now let's look at a few examples, just talking about parallel and perpendicular lines. Okay? So here I have a line. I'm just going to look it like this. Here we have a line, y equals 4x minus 2. What's the slope of a line that's perpendicular to it? Sorry, that's parallel to it. So here's my y equals 4x minus 2. Suppose I have another line that's parallel to it. What would I know this, my blue line, what its slope will be? Well, what do we know about parallel lines and their slopes? We know the slopes are the same. So that means this slope would also be 4. Okay? What's the slope of something perpendicular to it? So that means it would go in the other direction. It would meet at 90 degrees. Right? So what's perpendicular to 4? So if this one's positive, the one that's perpendicular would be negative, and you flip 4. If you flip 4, remember the denominator there is a 1, you flip it, you should get 1 over 4, and the sign changes. Okay? So the last one. You're given 2 slopes. You're going to tell me whether or not the lines would be parallel, perpendicular, or neither. And when you're asked to justify, justify means why. How do you know you're right? So if you just tell me parallel or perpendicular and you don't tell me why, you haven't really answered the question fully. Okay? So let's look at this one. Sorry. Can you just move it? Sorry. Here I have a slope being 4 over 6 and another one being 2 over 3. If I look at it too quickly, I look at it and I say, okay, well, those are different numbers. But if you reduce 4 over 6, what do you get? You can divide this by 2 and this by 2, you get 2 over 3. So these are actually parallel because the slopes are the same. Hold on, shouldn't be here. Sorry. So take 4 over 6, reduce it to lowest terms, you get 2 over 3. So the slopes are actually the same. So if you've got fractions, make sure you reduce them, okay? Let's look at the next one. Negative 1 over 3 and 3. So they're not parallel because they're not the same, but are they perpendicular? So you should be looking, is one positive, one negative? Yes. If I take 1 over 3 and I flip it to the reciprocal, do I get 3? Yes, because 3 is the same as 3 over 1. So this is perpendicular since the slopes are negative reciprocals. Let's look at another one. The slope is 2, and then another slope is 1 over 2. Are they parallel? No, because they're not the same. Are they the reciprocal of each other? So if I flip 2, do I get 1 over 2? I do. They're the reciprocal of each other, but look at their signs. They're both positive. In order for it to be a negative reciprocal, one must be positive, one must be negative. So here they are neither, okay? Because they're not negative reciprocals and they are not the same. And that's it.